Hello everybody and welcome. In this video I'm going to show you how to set up an ESD workstation in your house or apartment so that you can handle your 18F4550 or other ESD sensitive chip without doing electrostatic discharge damage to it. Caution: some of the footage in this video involves working with mains electricity, in other words the outlets in your house or apartment. Mains electricity is 120 volts alternating current. In the United States it could be different depending on what country you live in. But in any case, in any country, mains electricity is enough that it can kill you. Use common sense, double check yourself, stay sharp, and do not continue if you have any doubts or do not fully understand any part of this video. Going forward, you accept 100% of the responsibility for any damage to life, limb, or property. Continue at your own risk. So before we get into some of the practical aspects of setting up an ESD workstation, let's do a quick crash course in ESD theory. Your body can hold thousands of volts of charge. For example, you might be able to recall times that you took warm clothes out of a dryer and heard sort of a crackling sound, or you may have purposefully scrubbed your feet on a fuzzy carpet and then touched somebody else to shock them. The thing that we need to consider is that static electricity discharge that's even far less than can be felt or heard by people can still be more than sufficient to damage ESD-sensitive electronics parts. Something else that we should also be aware of is the difference between TTL chips and CMOS chips. TTL is short for transistor to transistor logic. When ICs were first developed, TTL chips were standard, but as time's gone on, we've demanded more and more from our ICs. They've had to get smaller and smaller, and they've had to have more and more transistors on them. And this has resulted in more and more crowded chips, which inherently are more static sensitive. Particularly today, most chips are CMOS chips. That's short for complementary metal oxide semiconductor. So pretty much all modern ICs, including almost all microcontrollers such as the 18F4550, are CMOS chips and therefore ESD sensitive. I won't get into ESD theory anymore at this point. I'd like to get into the practical aspects of it next, but if you're interested, there's plenty of resources on the internet. For example, if we type in ESD, we'll get the Wikipedia page on electrostatic discharge, and there's this nice section here on damage prevention in electronics. Similarly, if we type in TTL and we follow a few links, we'll get to the Wikipedia page on TTL chips, or we can type in CMOS and we'll quickly get to the Wikipedia page on CMOS chips. But rather than get bogged down in theory, let's go on to the practical aspects. So here's the idea. We're going to have the 18F4550 or other ESD sensitive chip grounded at all times. So if ground's down here, what goes in between? Well, of course, we're handling the 18F4550, and then we have an ESD mat, and then we have to connect that mat to ground. So, of course, our hand holds the 18F4550, so then we're going to use a wrist strap and wrist strap cord to connect ourselves to an ESD mat, and then we're going to use a ground cord to connect the mat to ground. So, of course, it's essential then that we have an ESD mat kit to set up our ESD workstation. Personally, I recommend getting one from esdmat.com. This part number specifically, we'll take a look at that in a moment. Also, you don't want to just toss your ESD sensitive chips in a drawer. They can touch the drawer itself, other parts. That's not good. That can also do ESD damage. So what you want to do is you want to get yourself some ESD bags to store your 18F4550s. And here's a recommended part number at Electronics Express. Also, once you get your nice new ESD mat, you want to get some ESD mat cleaner with that, because you really don't want to use general household cleaners with your ESD mat. They leave a residue which can reduce the mat's ability to dissipate charge. And in the case of severe household cleaners, cleaners with bleach in them, that kind of thing, they can corrode the mat. Also, if you use hand lotion often, like especially in the winter if your hands get dry, you want to get some ESD hand lotion, which is nice because it does not leave a gummy residue like regular off-the-shelf hand lotion does. So now let's take a look at www.esdmat.com. And these nice work surface mat kits here are probably what you want to get. You can get all the parts individually, but I recommend a kit. Specifically, I recommend these high temperature mat kits. And these have a nice thick rubber layer on top, so they're kind of resistant to scratches and abrasions and so on, so you can do assembly on them without worrying about damaging them much. Also, these mats will withstand soldering iron contacts. This is critical because at some point, no matter how careful you are, you're going to end up touching a hot soldering iron to the tip of your mat. Make sure you get a mat that can withstand that. I definitely recommend getting the biggest mat you possibly can because you're going to use all the room that you have. You always end up filling it up inevitably. So I'd recommend the 3-foot by 4-foot mat. Okay, so the first thing you're going to want to do when you get your ESD mat kit in the mail is unroll the mat on your desktop and then take a look at the other parts that come with your kit. And here's what you're going to find. You're going to find a wrist strap cord, and a ground strap. Now the wrist strap has two ends. This end here, the banana jack end, goes into one end of the ground cord. The other end simply goes into the wrist strap. So then once we've made those connections, and you'll notice there's metal here to make it conductive. So once we've made those connections and we put our wrist strap on, at that point, if this is grounded, then we're grounded. So that brings us to the other end of the ground cord, which is this loop. So we're going to have to ground this either through the ground of our wall outlet, or we'll have to take it to an actual piece of metal such as a pipe or a radiator that's going into the ground. I'll get to that in a moment, but first let's do some safety checks on the parts that we have. So if we connect across the two ends of our wrist strap with our multimeter, and I have my multimeter set to ohms, so there's one end connected to the banana jack, slight tripod adjustment, and now I'm going to connect, I'm going to zoom in just a bit. There's one end connected to the banana jack, and now the other end connected to the snap. And these purposefully have a 1 mega ohm resistor in them to keep you safe if there's anything wrong with your ground, if it accidentally gets shorted to power. So as you can see there, we're reading 0.98 mega ohms, or about 1 mega ohm. So our wrist strap has this safety resistor in it, just as it should. Similarly, we can take a look at our ground strap, or our ground cord rather. So of course we have our two ends, the end that we're going to ground and then the end that goes into the snaps on the mat. Most mats have snaps on two corners. There's one on one corner, there's one on the other corner. We'll insert that once our ground is good. But first let's examine the cord. So I'm going to put one end of my multimeter, still set to ohms, around the ground loop, and the other end I'm going to touch to either of the banana jacks of the snap, and we should get essentially continuity there because we're going directly across the wire, and sure enough there we have 0.2 ohms, 0.3 ohms, and bear in mind the leads of the multimeter are probably about that much, so essentially we have perfect continuity there. Now for safety reasons, if we go to the snap, just as with the wrist strap cord, to insulate us and keep us safe, we're going to have a 1 mega ohm resistor placed from there to there. So when we go directly to the snap, we're going to see about 1 mega ohm of resistance, and there we are, 1.05 mega ohms. So these cords are working as they should be. So now the next step is for us to ground this loop end.